And so having said that, I'm gonna go through so problem solving strategy. The way that you're gonna solve these problems is first read the problem very carefully. And so this sounds very normal, but most of my students make the mistake when they just read through the problems once and then they start like writing some things out and then they start reading it again and trying to find clues from it. It is not a very effective strategy because it takes you twice to read the problem, but it doesn't really make sure the fact that it doesn't ensure that you understand the crux of the problem. And so when you read the problem carefully, kind of like the first time, make sure that you get those quantities in your head, because the second step is going to be drawing the diagram. And I highly recommend doing this for all problems because it's really helpful to kind of like put everything put everything put every quantities into a pictures. And drawing a diagram is the way that you kind of like geometrically relate those quantities together. Next step is going to put the quantities, the given one and the asked one, into math symbols and assigning them as the function of time. And this is a little bit hard to do because it asks you to know a lot of relations. Say if you are given a volume of a cone, you have to understand how it related and know the relationships between the volume of a cone and say its radius and its height. Also, you'll be need to ask like putting the asked quantity, so the quantity that you have to find, into math symbols. Kind of this is the step where you relate what you need to find and what you already have, and this comes from the diagram you draw before. So the key thing in this type of problem is finding the relationships between those quantities, which is sometimes hard and sometimes very obvious, say if you relate them by Pythagorean theorem. So next step, identify the key relations between these quantities. Solve the problem using derivatives, and this is using both chain rule and sometimes even implicit differentiation. And so make sure that you review those sections, especially chain rule, because sometimes forgetting chain rule can completely ruin your problem solving because it doesn't allow you to identify where is your unknown. So make sure that you know that, and then plug in the correct expression to find the desired variable. The last step seems very obvious, but some of my students make the mistake last semester in the exam where they kind of like email me at the end and tell me, okay, I put this thing wrong into that, or like I don't know where I get it wrong, where they told me all of the step and they got it wrong at the end when they plug it in the wrong number at the wrong position. And so um so that's the step that you guys gonna use to solve this section. So I think in this sections the key point is that you do a lot of practice, because that's how you kind of like putting yourself into the situation where you have to put all of the quantities into a diagram and find the relationships among them. And it helps in the fact that it doesn't count at your grades when you do a lot of practice. And you can also, like, if you don't know like what to do in that problems, you can always Google it for the relationship, especially like those volume of thing. And but it's harder if you're given something like a subtle Pythagorean theorem or something similar to that. And so example one is saying, so you have a top of a ladder sliding down a vertical wall at a rate of that. At the moment when the bottom of the ladder is 3 meters from the wall, it slides away from the wall at that rate. How long is the ladder? And so this is a very classic problem for these questions. And in reality, the first thing when it comes to your mind when you have a ladder is like this. It's leaning over the wall. And so kind of like the wall is a vertical wall, and then you have, this is the bottom. And so the first thing that should come to your mind is that, okay, we're going to use something similar to Pythagorean theorem here, because that's the most basic principles that we use whenever we have a right triangle. And so it's saying this top thing is going down at a rate of 0.15 meter per second at a moment where the bottom is 3 meter from the wall. It lies away 0.2 meter per second. And now let me call this thing x and y. And so this is the length. And so the first thing is that putting them, first step is, okay, we read that carefully, we draw a diagram, we identify the quantities, and so we need to find L when x is equal 3 meter dy over dt. So this is the change of the height with respect to time, and it says it's decreasing because it's lying down. And so this is negative 0.15 meter per second. Dx over dt is 0.2 meter per second because it's lying down, and so x is increasing. And so now let's find what we have. So initially we have, so the relationship between them is x squared plus y squared is equal to L squared. Now, first thing we should try is to see if we can use Pythagorean theorem to find this thing. And I kind of like have a feeling that we're not going to be able to find it because we're missing some quantity here, in a sense. But let's see how it goes. Okay, so we have, if we take derivative of both sides of them, because looking at the problem statement, we have dy over dt and dx over dt, and so it gives us the fact that, okay, we have to take some sort of derivative to see what happened. And so if we take derivative of both sides with respect to t, then we have 2x dx over dt. This is where the chain rule comes into the way, because x and y are both a function of time. And so when you take derivative of them with respect to time, dx over dt would not going to be cancelled out as 1 because it's changing as time. Because here you're looking at that dx over dt is a different constant than dy over dt, so we have to keep them unless it's 1. Then if not, you cannot discard them. 2y dy over dt. However, the length of the ladder is always going to be a constant regardless of how fast and how slow the ladder is sliding down, and maybe even like sliding up by someone pushing it. But because it's always a constant, then it's 0. Okay, so now we can solve the problem. So when you have, so now what you end up having is that you have x dx over dt is equal to negative y dy over dt. And so you need to find y at that point. Because you have dx over dt already, dy over dt already, x already. So you need to find y. So you have x dx over dt divided by negative dy over dt. Remember, when you have some distance decreasing, it is a negative rate of change, which is what we have here. So we have 3 multiplied 0.2 divided by 0.15. What we end up having is 0.6, so it's 4 meter. Now, because L is always going to be constant, and using the Pythagorean theorem, now we can find what is L. So we have x squared plus y squared is equal to L squared. So our L is going to be square root of 3 squared plus 4 squared is equal to 5 meter. So the question is not hard, but the key point is that we follow the steps and giving out like all of the quantities into rate of change and unknown quantities. Make sure that you assign the right sign for them. If it's decreasing the distance, then it's negative change, and if it's increasing in distance, it's positive change. And so make sure also that you know which quantity is a constant. So when you take derivative, you make sure that that derivative of that quantity is 0, and which one depends on time. So you make sure that you take care of the chain rule, just like x and y here. Now, having said that, let's go to the second example. It's slightly more difficult, but it's based on the same principle. So we have a lighthouse is located on a small island, 3 kilometers away from the nearest point. So this is the key. So small island here, and the shoreline. So the shortest distance is always going to be the perpendicular point. So kind of like, I don't know how it calls in English, but kind of like the point where you take the perpendicular straight line here. So this is going to be P. This has to be a right triangle, a right angle, and it's line making 4 revolutions per minute. So how fast is the beam of light moving along the shoreline when it's 1 kilometer from P? So there are two other details we haven't used in the problem statement, which is 4 revolutions per minute and 1 kilometer from P. And so we have, when it's 1 kilometer from P, how fast is this thing moving? And so by here we have, this one is 1 kilometer, and this one is moving at 4 revolutions per minute. And so the first thing, I would try to convert the revolution per minute into radian per second, so that we can kind of like find not this way, but this way, 4 revolution per minute. Because the way that it is moving is that this is a circular orbit. So having said that, so this is at the point where it's 1 kilometer. So we have 4 revolution per minute. It's 4 multiplied 2 pi over 60 seconds. And so that we have 8 pi over 60. Or we have 2 pi over 15 radian per second. Now what you need to find is that you're gonna, so okay, so again, this is kind of like similar to some sort of Pythagorean theorem, but instead of using the normal Pythagorean theorem, you know the fact that when your light going over here, then you have a different quantities, but you're not given the rate of change of any of them. So what you're gonna do is that instead of using Pythagorean theorem, we also have other relations of a right triangle. So it's going to be, which is going to be trigonometry. So you have tangent of, I would say, this point, this angle, theta at that point is x over 3. So I'm calling this one x. And so when you take derivative of both sides of the problem, it's going to be, give me a second, put in the battery. So I forgot one thing that we have to find, which is we have to find what is, oh shoot. So this is not what I, So let's write another one. This is actually this way. 4 RPM. I actually don't know how it's physically look like, but I know the fact that it has to be perpendicular. So just let it be. And so what we need to find is that we have to find what is dx over dt. When you have x is equal to 1 kilometer, and so here we have derivative of tangent theta is secant square theta, d theta over dt. Make sure you take care of chain rule here because that angle is changing. Multiply dx over dt, multiply 1/3. Because this tangent is x over third, and so the fact that this one is always going to be a constant, giving us actually this is not really right because this is not always constant. Give me a second. Okay. Okay, so now we're gonna have d theta over dt, and so this one, when you have this quantity, is going to be d theta over dt. It means that how fast the angle is changing. And so by doing that, we're gonna have, at that point where you have x is equal to 1 kilometer, secant theta is gonna be 1 over cosine theta. And so at that point you have, by Pythagorean theorem, you have the hypotenuse be square root of 10. So, and so you have it's going to be hypotenuse divided by adjacent, which is 3 divided by square root of 10. And so doing that, we have dx over dt is going to be equal to 3 secant square theta, d theta over dt, which is 9 over 10. 3 multiply 9 over 10 multiply 2 pi over 15, which is going to give us 54 pi over 150. And if we continue to further simplify them, we're going to have 8 pi over 25 radian per, not radian, it's kilometer per second. And so that is my answer for this questions. It's kind of a little bit confusing here, so I'm trying to like make it I do think that you're gonna expect something like this. It's not gonna be this difficult, but it's gonna lie between the previous problem and this one. I think I'm looking at, okay, I'm not gonna have access to your actual exam, but I know her style of writing exam. So it's not gonna be too hard because this one is gonna take you like 20 minutes on the exam, and it doesn't make any sense to put questions like that in the exam. But I do think that you should expect something like this because I know her exam is getting harder and harder based on the feedback of previous student. If they say, okay, the exam is too easy, then it's getting then she's gonna write a little bit harder. Or it's not like, okay, she's pushing you guys over the beyond what you guys should expect to see, but she's gonna put it in a way that makes sure that if you get a high score, it means the fact that you guys show a mastery understanding of the material. And so, I mean, a master understanding of the material, including the fact that you have to be able to solve this kind of problems. So, okay. So, having said that, I'm gonna look through these questions again because it's a little bit confusing to me. And I'm gonna get back to you guys as soon as possible when I write down an email to everyone. But without any further thing, I'm gonna go through the exam review. And so, the topics that you guys should be starting to review is that it includes things as easy as like limit. Well, this section I didn't really go over at the beginning of the class because I think it's a pretty basic one, and I think it's more beneficial to read about the squeeze theorem in the book because it proves the theorem, and it also shows a lot of like examples where you can see, okay, how we're gonna apply this kind of theorem. And so, and next thing is continuity. Continuity is like one of the key thing of the materials where you learn about like all the three basic conditions where you have continuous function. And then we have the intermediate value theorem, which allows you to like prove the fact that, okay, you have at least one root in this interval. And then you have differentiability. This free part, this free topics is more like conceptual, where you learn like this, but you need to know these conditions. So conditions, you have derivative at x equal a of fx, relationship between differentiable and continuous. So how you like, okay, a continuous function is might be differentiable, but a differentiable function is always continuous. Or when you reverse negate the statement, so if you have a discontinuous function, it will never be differentiable. But if you have an undifferentiable function, it doesn't mean that it is immediately continuous. Like there are two conditions that lead to the fact that you have an not differentiable function. Failure to, and know when you have an undifferentiable function. So say like functions that when you graph it out, it has like a sharp corner, or you have like something related to absolute value. Usually is the case that you have undifferentiable point. And then you have derivative. So a lot of things to know about derivative. You need to know how to find derivative at a point by definition, and how to find derivative as a function, also using definition, and know those rules of product rule, quotient rule, chain rule. Then after that, you have a sections that, okay, giving you the formula of how to find derivative without using the definition of a limit, and also know that one. Knowing chain rule, and especially implicit differentiation. This one has a lot of applications, and it's really important because I think this is like the most practical part in the derivative sections that you're going to use in your field of study, like statistics or something like that. Even some other biology, I don't know what bachelor degree that you're obtaining, but that is where you're going to use derivative into your field of study. And then know their application in physics and solving world problems, which is what we're going over in section 2.8. Again, I didn't really going over a lot of problems in these questions, but I would highly recommend trying. In the meantime, is question 4, 8, and 45, and I think one more is 37 in the book. These questions is really helpful in the sense that it gives you kind of like the basic of the relations. So what kind of relations that you will be able to expect in the exam. I mean, it should going around just like volume, triangle, and maybe like some sort of like perimeter and circumference of a circle, something like that. It wouldn't go over too far, like, okay, how to find the volume of a very complex shape, or like the relationship between some very high level of physics with time. So it wouldn't go that crazy. It should be whatever you do in the practice problems. The fact that, okay, her exam, I know the fact that it's not going to focus on anything that any particular thing that I already gone over. She can give you anything in the practice problem, so beware with that. But if you're going through all the practice problem, I think you're in a really good shape for the exam. And so having said that, next week, again, I'll hold a last minute exam review for midterm 1. But it's just going to be the questions that I found, the fact that you guys, oh, it's 2.8. Sorry, it's 2.8 when I talk about problem statement, problem solving. And so next week, I'm just going to try out the hard questions in your practice exam. So I'm going to look through your result in the class of the problem who already did the practice exam and figure out what questions that you guys did wrong the most, and I'm going to going through them. I'm not going to going through the entire practice exam because some sections of that counts at your point. So again, please don't procrastinate until the last minute to do the exam, to do the practice exam, just because I'm gonna going over it. It's not helpful. It's not a helpful preparation. So beware with that, and I'm gonna see you guys next week. Thank you for that, and I'm gonna try to go over the second example again and make sure that I give you guys the right answer for it. Okay, I'll see you guys next week. Thanks for coming today, guys.